Okay, today we're learning 4-5 in the book, which is about factoring. We reviewed about factoring yesterday, and now we're going to do some word problems. So, example 1, Kiana painted a rectangular wall blue to start an ocean mural. She used 3 cans of paint, each of which covered X square meters, and a different sized can that covered 12 square meters. What are possible length and height dimensions of Kiana's mural? So the expression 3x plus 12 represents the area of the mural. So we're working with this. So what we need to do is we need to factor. So we need to look at 3x plus 12, and we need to think, what is the GCF of 3x and 12? What is the biggest number that goes into both 3 and 12? Well, it's 3. So we can take out a 3, make our parentheses. 3 times what is 3x? Well, 3 times x is 3x. 3 times what is 12? Positive 4. So this is our factored expression. So what this might look like in a diagram is it might look like it has a width of 4 and then a length of x plus 4. So maybe this is x and maybe this is 4. So the entire thing is x plus 4. This piece, 3 times x is 3x. And then this piece, 3 times 4 has an area of 12. So then that's where they get 3x plus 12. That's what it would look like in a model. Okay, next we're going to do the try it. Use factoring to write an expression for the length of the pool with the given width. So we need to think 4 times what is 4x plus 20. So we can just factor this. And 4x plus 20, what is the GCF? What can we take out? We can take out a 4. If we take out a 4, we're going to be left with x, because 4 times x is 4x. 4 times what is 20? 5. So the length of the pool is x plus 5. So it's 4 times x plus 5. Convince me, how can you use the distributive property to check the factored expression? Use the factored expression for example 1 in your explanation. So what we can do is we could take our factored form, which was 4 times the quantity x plus 5, and we can distribute the 4 to the x and the 5. 4 times x is 4x. 4 times 5 is positive 20. Okay, and that gets us back to the 4x plus 20, the area of the pool. So basically, we can use distributive property to expand the expression. It also says use the factored expression in example 1 in your explanation. I just use the factored expression here, but you can do the same thing with this one. You could do 3 times x is 3x, and then 3 times 4 is 12. And we talked about that. Okay, example 2. Factor expressions with negative coefficients. Rodrigo and Jordan each factored the expression negative 2x minus 6. Who factored the expression correctly? Okay, so basically what Rodrigo did is he factored it to, he pulled out a 2, and then he made it 2 times the quantity of negative x minus 3. Well, let's see if we distribute this if we get back to negative 2x minus 6. 2 times negative x is negative 2x. 2 times negative 3 is negative 6. Is negative 2x minus 6 the same as negative 2x minus 6? Yes, so he's right. Let's check Jordan. Jordan factored out negative 2 times the quantity x plus 3. So let's distribute it. Negative 2 times x is negative 2x. Negative 2 times 3 is minus 6. Negative 2x minus 6 is the same as negative 2x minus 6, so it's the same thing. So you have the choice of factoring out a negative like Jordan did, or you don't have to. And they're both going to still get the same thing. They're both equivalent expressions. So for this next try it says show two different ways to factor negative 4x minus 28. Oh, by the way, it said who factored the expression correctly. They both factored it correctly. Okay, so anyways, what we're going to do is we're going to think, what can we factor out of negative 4x minus 28? So I know that I can take a 4 out of that. So first, we're not going to factor out the negative. So if we don't factor out the negative, I'm going to write the original expression up here, so it's right here. If I don't factor out the negative, I could just take out a 4, and then I have to think, 4 times what is negative 4x? 4 times negative x is negative 4x. 4 times what is negative 28? That would be negative 7. So this is one way to factor the expression. Now the other way is we can take out the negative. So if we factor out negative 4 instead, we can say negative 4 times what is negative 4x? That would be x. And then negative 4 times what is negative 28? That would be positive 7. Be careful with this. You might want to put negative 7, but remember, if we put a negative 7 here, that would be negative times a negative, which is a positive, which this is not. Okay, so negative 4 times 7 is negative 28. So that's another way to factor it. So those are the two ways. Next, example 3. Factor 3-term expressions. So use the GCF to factor the expression. 6x minus 18 minus 12. So we have to think, what is the GCF? What's the biggest number that goes into all of those numbers? And that is 6. So if we take out a 6, we're going to be left with 6 times what is 6x? That would be x. 6 times what is negative 18? That would be negative 3. 6 times what is negative 12y? That would be negative 2y. Next, try write an equivalent expression for the expression above using a negative factor. So basically, instead of taking out a positive 6, this wants us to take out a negative 6. So if we take out a negative 6, we have to think, negative 6 times what is positive x? Negative 6 times negative x would be positive 6x, right? Because a negative times a negative is a positive. Negative 6 times what is negative 18? That would be positive 3. Negative 6 times what is negative 12y? That would be positive 2y. So as you can see, all the signs here just flipped. We factored out a negative 6 instead. Positive x became negative x. Negative 3 became positive 3. And negative 2y became positive 2y. Okay, do you know how? Sahil is putting together supply kits and has 36 packs of X pencils and 12 packs of Y crayons and 24 erasers. Write an expression to show the total number of items. So he has 36 packs of X pencils. That's 36 times X. He has 12 packs of Y crayons. That's 12Y, so plus 12Y. And then 24 erasers, that's plus 24. Next, use factoring to show how many kits Sahil can make while putting every type of item in each kit. So what we're going to do is we're going to think what number goes into both 36x, 12y, and 24. What's the GCF? The GCF is 12. I'm going to take out a 12. 12 times what is 36x? That's 3x. 12 times what is 12y? That will be y. 12 times what is 24? That would be 2. So how many kits can he make? He can make 12 identical kits. He can make 12 identical kits. Use the factored expression to find the number of each item in each kit. So basically, there are 3 packs of pencils. There is 1 pack of crayons. And lastly, there's 2 erasers. Show 2 different ways to factor negative 12x plus 24 minus 18y. So first we could take out a positive number. So what goes into both 12, 24, and 18? That would be 6. So we could take out a positive 6. 6 times what is negative 12x? That would be negative 2x. 6 times what is 24? That would be positive 4. 6 times what is negative 18y? That would be negative 3y. That's one way. The other thing we could do is we could factor out a negative 6. If we factor out a negative 6 times what is negative 12x? It would be positive 2x. Negative 6 times what is negative 24? It will be negative 4, because a negative times a negative is a positive. Negative 6 times what is negative 18y? It would be plus 3y. So those are the 2 ways you can factor that. How can you use the distributive property to factor the expression 6x plus 15? So what we can do is we can think, we're first going to think factoring. So what number goes into both 6x and 15? That would be 3, so we could take out a 3. 3 times what is 6x? That's 2x. 3 times what is 15? That's positive 5. So basically we could think that the GCF is 3, and using the distributive property is really just checking your work. So 3 times 2x is 6x, and 3 times positive 5 is 15. So that's really the check. All right, now you're going to do your practice and problem solving. I really recommend not using the boxes because they're a little confusing. So don't use the boxes. So just do the first page of the practice and problem solving today. Okay, that's it. Have a great day.